Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about quality of meshes in hydrodynamics analysis in tools like ProteusDS. So why this is really important is if you don't have a good quality mesh as a starting point for your analysis, you really can't rely on the results, and they can be complete nonsense and be really misleading. And so obviously it's something you need to look at right away and just from the first step of analysis. So in the Proteus manual, you'll see a section on best practices for creating hydrodynamic meshes for the custom meshes that you may be working with. Here's an example of a really poor quality mesh. This is a STL format of a hull structure, and I mean it's just exported from a CAD program that's not really intended to be used for hydrodynamics analysis. It's just a faithful representation of the shape, but the discrete mesh that comes out of it isn't in any way, created with any kind of consideration for hydrodynamics. So it's not good because you have large elements next to really tiny ones, and the elements are also really skewed. Like they're not like a square aspect ratio. They're really long. So in a lot of places in the calculations, pressure is applied, at the centroid of area, and that's going to be representative over a large area of the hull. That's just going to be inaccurate. There may be some accounting for the distribution of pressure on it, but it's not going to be accurate. Lots of skewed elements here, way too many tiny ones here, and like maybe it's not too bad along here, but there's just like far too many elements over here. So it's poor distribution, poor aspect ratio, and really no real thought into like how many panels might be suitable. On the other hand, this is what it looks like after cleaning up in programs like Rhino or Blender or many other kinds of programs that are out there. So you see a more uniform kind of aspect ratio, uniform spacing, uniform sizing. Yes, there can be some little areas with some concentrations of panels and things like that, but that's okay. And let's look at a couple of other examples. So where do you see this coming up as well? In the Shipmo 3D toolset, if you're generating the hull mesh from the hull lines inputs, you do have some control on the aspect ratio, for example, and the limit on panel area. So changing the limit on panel area is going to result in bigger panels or smaller panels, and then the nominal aspect ratio is going to give you an idea of like how much skewness there might be in the mesh. And so you get some pretty good looking meshes out of this result with the built-in capability in the Shipmo 3D toolset. And where else you see it is if you're using a tool like Rhino. Here again we have a MOBS buoy. This is a surface buoy used in oceanographic applications. If you wanted to get that sort of specific shape, what does a MOBS buoy look like in reality? I've got a couple of nice pictures here. So it's a foam float, about 3 meters in diameter. Here's one being deployed. Another view from the other side, just showing that kind of chamfer there, right? So the quad remesh function in Rhino does a pretty good job of making a nice faithful representation. So this is being made from a surface file, from a step file from a CAD program. So Rhino has some pretty powerful capabilities for making nice meshes. They're not square aspect ratio panels out of this, and we could maybe play with the numbers here a little bit, but by and large, it's pretty good, and you got pretty uniform spacing. It's not a bad thing to have like some vertical distribution to get a nice variation in the forces on the wetted area of the hull from the static and dynamic pressure as the hull is coming in and out of the water. But this is a really nice looking mesh. Another example is in one of the other tutorials where we made a little 20 meter by 20 meter by 2 meter box barge. If you don't have any thought to after generating the shape and you just save it as an STL file directly, you'll get a mesh that looks like this, which is in no way suitable for hydrodynamics analysis. Again, big panels, really one here, very skewed shape. I mean, it's just you can't use something like this. You need to apply a quad remesh, or use shrink wrap and quad remesh on a file that looks like this to get a sensible mesh out of it. So really the two things to kind of look for are Kind of like the distribution of the panels should sort of be gradually changing in size or fairly uniform, and the aspect ratio as well. Try to keep them sort of uniform, not big pizza pie slices that are skewed all over the place. So hopefully that helps to give you some ideas on quality of the mesh. Thanks for watching.